All right, so here we're going to be going over combinations. To this point, we have already covered permutations, the counting principle, and now we're going to go on to these little things called combinations. So first of all, what in the world is a combination? A combination is an arrangement without regards to order. And we have the formula here. So when we want to figure out what is the combination, we use this little notation here where we have NCR. And in order to calculate this by hand, you would have to use this formula here. The numerator would be your n factorial, and then your denominator would have n minus r factorial, and then times r factorial. So pretty much you are going to be using this formula if you were to figure out something by hand. But if you notice throughout the problems we're going to be doing today, we're just going to be using our calculator. Now, like I said, we've already covered permutations, and now we're going to go into combinations. So I have to make sure that you know the difference between both of them. So like it was defined earlier, a combination is an arrangement without regards to order. If you remember the definition of a permutation is an ordered arrangement. So pretty much the difference is that a combination order does not matter, and in a permutation order does matter. So for example, if I were to tell you we're going to do a race, and the first three people who win the race are going to get different prices, right? First place is going to win $500, second place is going to win $100, and third place is going to win $50, then that means that order does matter. So that would end up being a permutation. Now, if I tell you a different example, if I tell you we're still going to run a race, but the first three people who win are each going to get cupcakes. So in that order, in that example, order does not matter, right? If you end up in first place or in third place, it doesn't matter. You're still going to get a cupcake. So that would end up being a combination. Okay, so make sure you know the difference between both of them. Now, let's go ahead and start with some examples, right? So first thing I want to know is just make sure that you know how to read this. So this, if you see a C in the middle, it means that it's a combination, not a permutation. And the way you would figure this out is simply using either the formula if you were to do it by hand, but we want to make sure you guys know how to use a calculator. So if you were to put this in a calculator, it would look like this. Again, I cannot show you here how to input it, so make sure you watch the two videos below, depending on what type of calculator you have, so you can see how to input this correctly. But you normally always have to put the number first, so you put the first number, which in my case would be 10, and then I would put the NCR function, and then I would put the second number, and then simply click enter, and that will give you your answer. Okay, so that is the way you do this. Again, if you want to know how to do this in the calculator, please watch the two videos below, and it tells you exactly step by step how to use your calculator. Now, same thing, I just want to make sure you know how to use this. So again, you put the first number, and then you put the NCR function, and then 0, and then that gives us 1. And the reason I put this one in here is just so you could practice and just know from now on, every time you have a 0, so anything combination 0 is always going to be 1. If you want to double check on your calculator, go for it. But it's nice to just know, right? So every time you see something combination 0, you could just straight ahead and be like, you know what, I know this is going to be 1. Now, this is where it gets interesting. Since we've already gone over permutations, I could throw this in here. This is a fraction where we're dividing a permutation by a combination. The way you do this is don't panic. Just go ahead and calculate each one individually. So in my calculator, I do the top part, 9 NPR 2, and I get 72. And then separate, I do the denominator, which is 11 NCR 7, and I get 330. Now, of course, this is a fraction, so I have to put 72 over 330. And again, you have to make sure you simplify. So 72 over 330 simplified is 12 over 55. And that would be my final answer. Again, if you do need help simplifying, please let us know. We will gladly help you. But all you have to do is just make sure it's simplified to the lowest terms, and that would be your answer. All right, let's go ahead and try one more. Again, this one has two combinations. So it's just like the last one, but of course we have to use a combination function on both of them. So for the numerator, I have 8 combination 5, and I get 56. And then for denominator, I have 10 combination 5, and I get 252. And then I simply put those in a fraction form. Again, every time you have a fraction, you reduce to the lowest terms. And 56 over 252 simplified is 2 over 9. All All right, here's where it starts getting interesting. On your online homework and on your online quiz, even on your test, we're not going to tell you, hey, for this one, use a combination or use a permutation. You are going to have to defer and know which one to use and when. So let me go ahead and read this problem. So in this one, we have that Peter has 22 different books and plans to donate 6 of them. How many different selections of the 6 books are possible? So the first thing you have to notice is that we have a total, which is 22, and out of those 22, 6 are going to be chosen. Now, anywhere in that problem, does it say anything about the first book going to Goodwill and the second book going to a middle school and the third book? No, right? So that means that order does not matter. And since order does not matter, this is how we know that this is going to be a combination problem. So all we have to do, you're going to set this up as 22 combination 6. Again, because we're just choosing 6 books and all 6 books are going to be donated. So that's all you have to do. Take out your calculator, input this in, and that means that there are 74,613 different ways that Peter can donate 6 books. So that's pretty crazy. But again, that's all you have to do. So just make sure you read the problem, ask yourself, is this a combination or permutation? Set it up and then just calculate it. That's all you have to do. All right, next problem. Ms. Smith must select 7 students from a group of 14 students to enter competition. In how many ways can this be done? Again, this is just like the last example. Students are going to be chosen. The order does not matter. All 7 students chosen are going to go to the competition. Doesn't matter if you were chosen first or chosen last. You're going to be treated the same way. So let's just go ahead and see the 2 numbers here. There are 2 numbers in this problem. Make sure you put them correctly. There's 14 students total, so that's your first number. Out of the 14, we're going to select 7. So this is why it goes like this. Please do not put the smaller number in the front. The total always goes first. So 14, combination 7, I put that in my calculator. That means that there is a total of 3,432 different ways that Ms. Smith can choose 7 students from the 14. All right, next problem. For a lottery ticket, 7 numbers in any order must be chosen from 1 to 55 inclusive. How many different sets of 7 numbers can be chosen? Again, this is a lottery ticket. What gives it away is this right here, right? So this one actually tells you in any order. So who cares what order you pick them from? They're still going to be used for the lottery ticket. So this one is going to be a combination, right? Combination order does not matter. So let's see, how many numbers do we have in total? We have from 1 to 55. Don't let this word freak you out. Inclusive just means that you can include the 1 and then you can include the 55. So that means you have a total of 55 numbers. And we have to choose how many? 7, right? We have to choose 7 numbers. So pretty much that's all you have to do. 55 combination 7 because we have a total of 55 and we're choosing 7. Put that in your calculator and look at that huge number, right? So that means that is how many different ways you could fill up a lottery ticket, right? So we have 202,927,725 different ways. So that's why the chances of winning the lottery are pretty crazy, right? Because those are all the different combinations that exist. So again, just because of the word any order, that gives it away that that's a combination. Sometimes you're going to get problems that say in a combination lock. So that pretty much also gives it away, right? It's a combination. All right, let's go ahead and try another one here. This is where it starts getting a little more interesting. So let me go ahead and read this problem first. So at the Dunder Mifflin office, the sales department consists of 7 people. So let me just go ahead and underline that. And the warehouse consists of 9 people. So now we're talking about 2 different departments. A team of 3 salespeople and 4 warehouse people will be selected to attend a conference. In how many ways can the team of 7 be selected? So again, this is where I told you it does get interesting because we start throwing 2 different departments in one problem. So don't freak out. This just means we're going to have to do 2 different combinations. And again, how do I know it's a combination? Because the order does not matter. I'm going to go to Dunder Mifflin and I'm going to select people from the sales department and they're going to go with me to the conference, and I'm going to select people from the warehouse department and they're also going to go to the conference. It doesn't matter who I choose first or who I choose last, they're all going to go to the conference. That's how I know it's going to be a combination. This would be a permutation if I told you the first person I choose is going to go in first class, the second person I choose is going to go in the bus, and the third person I choose is going to go walking. Then that's how you know that order matters. But in this problem, it doesn't, so this is going to be a combination. Now, to tackle this problem, you're going to have to divide it into two pieces. So this is what I did. You are talking about two different departments, so you have to set up two different problems. So let's go ahead and start with the sales. Sales has 7 people, and out of those 7 people, I'm going to select 3, right? 3 sales. So that's how I came up with this first thing. Now you also have to put warehouse people. So we have a total of 9 people in the warehouse, and out of those 9, I am choosing 4. So that's how you come up with the second one. Once you find those two numbers, you are going to have to multiply them. This is where the counting principle we've already talked about comes into play. So don't freak out, it kind of looks kind of messy, but all you have to do is put these in your calculator. Right, so I tackle the first one. This right here gives me 35. And then I put this second one, and that one gives me 126. And then like I told you, all you have to do now is just multiply them. So you multiply those two, and you should get your final answer, right? So if you multiply 35 times 126, you get that there's a total of 4,410 different ways that you could come up with your people to go to the conference. Okay, so that was pretty nice. Just remember, when you have different selections, you do them separately, but then at the end you just multiply. All right, let's go ahead and tackle one last problem here. So the Central Desserts restaurant offers a combo box where customers can choose what to put in it. So you're going to go, right, you're going to make your little box. Now, a customer can choose 4 out of the 7 donuts they have available. You can choose 4 out of the 8 cookies and 3 out of the 6 cupcakes. How many different choices are possible? So again, if this problem shows up on your test, order does not matter. Everything you choose is still going to go in your box. You're still going to eat it. So this is how you know it's a combination, right? There's no regards to order. You're not going to differentiate between the first donut and the last donut, right? You're still going to treat them the same. So this is a combination. Now, when you're talking about 3 different categories, so that's how you know you're going to have 3 different setups. And then at the end of the day, you're going to multiply those 3 answers together. So just like the last problem. Now you just put them in order, right? So my first one is donuts, right? So donuts. I have a total of 7 and I'm going to choose 4. So that's how you come up with the first. Remember, the first number is always your total. So 7 donuts total, I'm choosing 4. Now we move on to the cookies. There's a total of 8 cookies and you're choosing 4. So 8, choose 4. And then the last one are the cupcakes. You have a total of 6 cupcakes and you're choosing 3. Okay, so again, make sure you always put the total first. Okay, again, on the problem, the number 3 does come first. That doesn't mean you have to put it first. It's 3 out of the 6. So it's 6 combination 3. And just like we did on the last problem, go ahead and calculate every single one of those individually. So for the first one, I got 35. For 8, choose 4, I got 70. For 6, choose 3, I got 20. And then remember, what do we do after those? We multiply every single one of those answers. So you would do 35 times 70 times 20, and that gives you 49,000. So that means there's 49,000 different ways you could fill up your little box if you were to go to the Central Desserts table. So that's pretty much how you figure out those problems. If you do need help, if you need more examples, just let us know.